Okay, so here's our triangle. I'm told that I've got one side perpendicular, another side congruent, and from these two bits of information, I'm going to try to prove triangles are congruent. So let's look at the picture and see what, let's move these marks onto here, and then see what other things we can add, and what things we know. Now remember, with all of the triangle congruencies, I need to show three things are congruent between the two triangles. In this case, I'm trying to get this triangle, PQR, is congruent to this triangle, SQR. And the order of my goal tells me what angles are paired up, what sides are paired up. So P and S are both the first guys, so they should be congruent. Q, so this Q and this Q should each be congruent. And these two down here at R should be congruent. So that kind of helps me think about where I want to go with this. So I've got perpendicular, I've marked it on my picture. Does that tell me that these angles are congruent? Yeah, all right angles are congruent. The right angle theorem was one of the theorems we did in chapter 2. And that covers that base. I mean, you can also reprove it. They're each 90. If two angles have the same measure, then they can equal each other, and then if they equal each other, they're congruent. You can still get there. PQ is congruent to QS. Okay, so PQ is congruent to QS. All right, good. Those are now marked on the picture. Is there anything else I can mark on there from what I've been told? Or that I can figure out within a step or two? Oh, okay. This side is congruent to itself. Is that enough information? I've got three things. Which one do I be using? You're not in the head. Hypotenuse leg? Yeah. I've got right triangles because of the perpendicular thing. And I've got legs are congruent and the hypotenuses are congruent. That does it. It's the one time we're allowed side-side angle. So now we can go ahead and, now that we know our plan, we know what theorem we're going to use, I'll even make a note to myself. From my sketch, I'm going to use the hypotenuse leg as my theorem. So we can go ahead and say, all right, statements and justifications. I have my, I'll write this given first. PQ is congruent to QS as given. I'm going to write that first so that that's one of my checks, my check marks. One of my three marks of, yeah, that works. QR is perpendicular to PS. That's also a given. And that means I've got triangles PQR and SQR are right triangles. Definition of right triangle. Now this is where it's a little bit fuzzy. I don't believe the book has too many proofs that involve fill in the blanks with hypotenuse leg. So you'll see lots of different ways of making this statement. A lot of different ways of getting out there the fact that I've got my right triangles. The important thing is that you say it and that you have something to back it up that makes sense. I'm not overly worried about how you approach that as long as you say something to the effect of, yes, hypotenuse leg is a legitimate choice because I have right triangles. Some people even just say saying this alone is enough because it's perpendicular, therefore it's a right angle, therefore the right triangle. Boom, we know that. But it's important to get that fact out there on some level. And then my third fact we just mentioned was that QR was congruent to itself by the reflexive property. You'll see a lot of the reflexive property come up because it's an easy one for us to fit in there because it's easy to give you that freebie by making it a shared side. That's my third fact. I've got one pair of sides, in this case the hypotenuses, second pair of sides, the legs. I've got a right triangle, ergo PQR is congruent to SQR. by the hypotenuse-leg theorem, and that is indeed what I set out to prove. Me too. I love proofs. I think they're a lot of fun. It's the teaser.
Yeah, I don't love to prove.
Oh, this stuff. This part of proofs. Okay, that's fair. So it's a mystery. It's like reading Sherlock Holmes and getting to the answer before he does. All right, what else can I say?